This is Bean to Barstool, a podcast that looks at the intersections of craft chocolate, craft beer, and other artisan drinks. My name is David Nilsson. I'm a professional drinks writer, an advanced cicerone, the author of Pairing Beer and Chocolate, and the creator and host of this show. The music for this episode is by my dear friend, indie folk musician Anna P.S. You can find out more about Anna's music in the show notes or on annapsmusic.com. You can find links and information about our guests in the show notes as well. I hope you enjoy this episode of Bean to Barstool. Hey everyone, we're back for part 2 of my conversation with Sarah Bharath about cacao farming, cacao fermentation. We left off at the end of the last episode talking about the accumulated consequences of high intervention farming practices rather than letting the plants and the soil and the farm conditions kind of tell us what they need. So we're going to jump right back in on that. I asked Sarah about what farmers can do to begin to undo some of those practices and some of those consequences. How, and I'm not asking this rhetorically, how do you hop off of that treadmill? Because I mean, at the farm level, especially when you're talking about small holders, they need to make money. And
Exactly.
it's going to cost money to begin changing this, or at least make less money in the short term. So how do you actionably actually begin to undo these problems at the farm level?
Again, we go back to where it all begins. Many of our farmers do not understand how soil actually works, much less what they can do with what they have. We're not talking about fancy technology here. We can actually build soil with a machete, if I can be that facetious, right? If the machete is all the farmer has, and usually they'd have a machete, they'd have a hoe, they'd have a rake. At the end of the day, when you combine what a machete can do with pruning exercises, right, across all the plants in the system, we're not just focusing on cacao, because cacao is not growing, it's not meant to grow, and it's not meant to work alone, okay? And the farmer cannot survive off of just cacao. You can't eat cacao leaves in a salad, as far as I know. If we could, I'd be growing cacao like crazy, okay? We can't have it as a salad just yet. You have a lengthy time from flowering to actual successful fruit. And there are a lot of, as you recognize, there are a lot of things that can happen in between that 5 to 6 month period where you can suffer massive losses, okay? But the point is the farmer needs to have food for himself, his family, and the wider community. There may be commercial sale involved, there may be trading, there may be bartering of on-farm products, right? The fact that pruning is a huge accelerator of what happens in the system is a big entry point for me and many of us who work at ground level on farm now. Now that we have a lot more information as to how we can actually build soil in a shorter period of time. Yes, the geologists, we know from geological perspectives, it takes, what is the quote? I always forget the number of hundreds of years that are required to produce an inch of topsoil, working at nature's pace, right? But nature has shown us, if you leverage the principles of how I'm building this topsoil, you can actually build it in weeks, months, years, okay? We have a scenario, at least one of many, but it's a very, very well-known scenario, at least in regenerative circles, in Brazil with Ernst Gurch, down in Brazil on his cacao plantation, right? He has done in 40 years at the level of the soil what would normally take at least 500 years to achieve by regular nature's pace. And it's not that, why does nature take so long? Nature has all the time in the world. What is time? Time is a human construct, right? But we live in this space, this physical realm now, and we have all of these lessons coming from nature. And this is why getting people to understand very, very simple elements of biomimicry is so important, because they begin to understand, how does nature How does nature actually create its own? Nature doesn't create compost piles the way we create compost piles. But nature ensures that with the death and the falling of fruit, of leaves, breakage of branches, collapse of trees, there's a return of many different kinds of material in the same space, which then feeds the diversity that it wants to maintain in that space to help keep basically keep that engine running. So below supports above, which supports below, which supports above, and the cycle continues, okay? And it isn't a hamster wheel to nowhere. This is the engine of the earth. This is the engine of planetary existence, right? So we now have an understanding, thanks to all of the people who have been doing amazing work coming up through indigenous communities and what they've been doing, what they've been willing to share, traditional knowledges that have developed around that. And then, of course, the science has been trying to unpack, why does this work? How does it work? Under which conditions, right? We have opportunities now, and we're leveraging. This is not just we're referring to this from a textbook or some nice journal article. These are things that we actually have already running on farms at different scales that are transforming landscapes. But the key part has been, what don't we know that is now public information that needs to be tapped into? And so teaching farmers the power of, why do we prune? It isn't just to make this a pain in the, pain in the neck exercise for you guys. Prune just because we said to prune. No, it also isn't just about reducing the height of the tree so that in zones where you have the greater impact of, let's say, torrential rains, storms, etc., your trees are shorter, more manageable. They're less subject to that whipping action, because cacao is an understory forest tree, right? It is accustomed to little to no wind movement of the leaves. So you have it in an exposed environment where it's subject to all manner of intense sunlight, crazy wind movement. We've already set it up for failure. How do we mimic what nature has done? We need to create the community around it that's going to support it above, in terms of umbrella-like shade, if you want to put it like that. You're going to have shading at different levels, so it filters the light and the light intensity, but it also protects it from all of these crazy wind events, which reduces drying of the atmosphere, okay? It helps to maintain a more highly humid environment, both above and below. You're going to have all of these different root architectures and depths that now allow for differential food access, microbe access, diverse microbes, as well as you're talking about tapping into different strata now in the soil profile, okay? So the same way we're aiming for, like a forest system, you have different heights of trees, you have different functionalities of trees. We're aiming for different functionalities, depths, and structure of the roots to create that kind of diversity down below. And in helping farmers to understand, one, the design of these plants that they're working with, how the design fulfills the functions in the space that they're growing, and how the soil and the soil life is integral to all of that actually working as a system. The farmers now begin to see, wait a minute, this is actually something that I can do. This actually makes more sense to me. So I'm actually willing to prune now that I understand, with that one intelligent action of informed, appropriate pruning, I set in motion 360 degrees, all of these actions that I don't need to micromanage. If I know that pruning and mulching on the ground is going to help me keep water in the soil system, that prevents me having to go buy irrigation lines, pumps, and have to tap into municipal water supplies, for which I will have to pay exorbitant fees for that water. And I have to hope to God that the municipal supplies are not contaminated. Do you understand how many things we remove the micromanaging by simply understanding, what does this system need based on our current understandings of how the system works? And then what can I now, as the steward of that land, what am I required to do as part of that system versus being apart from the system, and trying to take very mechanistic approaches to, again, manage complexity that I do not understand.
We'll be right back.
Hey everyone! Gravel Road Brewing Company in downtown Middletown, Ohio, just south of Dayton, is brewing great beer and offering a full calendar of food trucks and fun events. Located in a former industrial building that's full of character, Gravel Road has a small, cozy bar space and a larger, family-friendly taproom area with a pool table and games. Head brewer Dan Loro is passionate about historical brewing traditions, so you'll often find styles like Munich Helles and Kentucky Common on tap. But yes, there's usually a hazy IPA too, if that's your preference. While you're there, you can say hello to Chicken Nugget, Gravel Road's resident brewery cat, who even has his own Instagram account. If you live in Cincinnati or the Miami Valley, or you're just passing through, head down to Gravel Road and check out this excellent brewery. And thanks to Gravel Road for sponsoring Final Gravity and Bean to Barstool. Do you think there's an upper limit to farm size where this is reasonable? I mean, obviously this gets it's more work the more land you have, but is there an actual functional limit to where this really is not doable?
That is really a good question. And to be honest, David, I can't give you a set number. I really can't give you a set number because it obviously is going to be influenced by the plants that need to be grown in that space, right? And what the let's say the company, the farmer really wants out of that system. Okay. So let's say, for example, we may not be able to mimic an agroforest, right? On 10,000 hectares of land, let's say, right? Let's go that big, okay? We may not be able to replicate a forest system in that regard, but this is where it comes back now to the principles of the process. Who is doing the work down below, and who, in inverted commas, who do they need to be, and what do they need? Where we have very large plantings, it's to basically now, how do we trigger the diversity of organisms in the soil, basically tricking them to think that there's this above ground diversity by creating signals in the soil system that will now get the communities to respond in a particular way, because this is what diversity above ground is fueling. It's providing chemical signals to the biomes that are in the space. And by their mere activity and existence, they are helping to create micro and macro aggregates, right? It's understanding, how does this underground economy work? Who are the players in this economy based on the crop that I want to grow? And how can I then support that, even if I'm doing let's say, a less diverse polyculture? So it's not going to be full-on agroforestry, but we can certainly have 4 or 5 species represented, and not necessarily at the same time. This is where crop rotation becomes an important part of the dynamic, where a farmer may not be interested in growing 4 or 5 different species of whatever at the same time, because it may make harvesting harder. It may make separation of harvested items a lot more complicated. So the crop rotation achieves similar ends, where when your main crop, and clearly we're not talking about cacao here, right? When your main crop, like your cereals, your grains, right? When they're done, you can now cover crop with something else that's going to pump the system, fill the system with a bunch of microorganisms that were not active before, but they're resident. They're there, they're now awakened, and they start producing chemical signals in the space that wake up other elements of the biome in that space. So that when you have to bring your crop back in, the diversity on the ground is ready to support that single crop, but you would have had multi-species growing in the same space. So we've separated in time, but not in space. Yes? And with the understanding, the microbiological understandings, now we've recognized that we can create certain extracts that we then feed the system with, where we basically trick the system into thinking that, oh, those plants are there, those organisms are there, but we've actually sent out the signals that those organisms would normally produce. So the system responds because it's recognizing the language, and so it will do what needs to be done. With cacao now, because of how cacao is designed, or rather designed, and it prefers to grow, there are things that we can do to simulate at scale, but are we willing? The question is, are we willing, David? Because when you begin to look at all of the industries that have grown up around monoculture, all of the industries that continue to develop out of monoculture systems to provide all of these emergency room supports, the intensive care supports, that's how I like to refer to it. We have all of these plants on IV tubes. We have to come in and defend these plants because we're simply seeing the soil/dirt that most of this cacao at scale is growing in. We see it as simply something to anchor the plant in, and we will do the rest. But there is tremendous opportunity, and it does not have to be. Ideally, great. A forested system, okay, but it's not going to work in all locations. It's not, okay? But what principles coming from that forested system above and below, how can we now leverage those intelligently to simulate and create a much more enabling environment than we currently have with large-scale production? The plants are in very hostile conditions, and they're propped up by all manner of micromanagement schemes. Yes? And so it's become highly technical and highly costly on top of it. Yes, it's producing more. It's producing more, but at what cost? Because it isn't just we have to have the irrigation and the high analysis fertilizer. It's all of the industries that surround those. And in the end, none of those things are helping to build soil structure that will allow us to harvest whatever moisture is available in the space. We're not shortening the water cycle between evaporation and transpiration water loss via the plants. We're not shortening the cycle to bring that moisture back into the soil. So we're tethered to the municipal supply, and we have to remain, in some cases, hopeful that rain is going to fall so that we can fill huge canals from which to irrigate. But when we're irrigating with runoff water that is poisoned by these chemicals that we're using, that is loaded with all of these soluble nitrogen, phosphorus, potassium fertilizers, you realize how we have basically created a closed loop of self-poisoning for those plants. So we're the hamster wheel to nowhere. When we have an opportunity leveraging biomimicry, we have an opportunity to create a soil system that is mimicking what should be happening, to then encourage what we call that soil sponge, so that we can have the infiltration, we can have the air, moisture, and then root room, okay, that allows these plants, and we're building the nutrition now in a way that allows these plants to actually grow the way they're designed to grow, and using natural inputs coming from waste coming from industries that are surrounding all of these operations, not necessarily physically, but they're in country, right? But again, as humans and as consumers of chocolates and cacao related products, right, we have got to ask ourselves some very, very hard questions about our consumption levels. Because I see it all the time on all of the fancy projects and mandates that go out to farmers. Sustainable production, and then there will be a tiny fine print reference to sustainable consumption. Are we consuming sustainably? That's not a question that I know the answer. It's not the answer I want to be able to give. Yeah, but we are not matching our so-called sustainable consumption with what the system can provide. And we're continuing to ask the farmers, and by extension, the systems, to produce more with less. And we keep thinking that we need to produce more to get ourselves out of the mess that we're currently in. And it's a formula that equation is never going to balance. Never. The mathematicians will tell you it's never going to work. So it comes back to why. And humans and our roles and responsibilities as active consumers and as industry partners, we have to ask ourselves some questions. Where do we cap? Where do we apply our ceiling to actually help the system now to begin to recover with intelligent interventions? But we don't seem to be willing to ask that question, because again, it comes back to the limitless production, limitless growth. And the system is going to say, okay, I'm going to go until I can't go anymore. And then maybe you'll learn. And we're seeing the signs of that now, but it's not impossible, you know. We're not at, I personally think we're not at the cliff's edge and falling off, because there are people on this planet doing incredible work at scale, showing us, listen, can you please pay attention? I'm telling you, I took the risk to try this and it paid off. What are we doing? Yeah. So we come back to the hard questions, and it always comes back to the why, because once you're willing to ask the why, you're going to find the how.
We'll be right back.
Hey everyone, you may have noticed things in the world aren't awesome right now, and social media kind of reflects that. I built a lot of the following for Bean to Barstool and just for my own writing career on Instagram, but I've been getting significantly lower returns in terms of engagement on Instagram, and well, some of their recent changes don't have me thrilled for the future. So here are some ways to keep up with Bean to Barstool if Instagram and other social media platforms don't prove to be long-term viable solutions. If you do nothing else, sign up for the Bean to Barstool newsletter. You can do that by going to beantobarstool.com/newsletter-signup. That link is in the show notes. That is a weekly email newsletter that covers all the same things we cover here on the podcast. Speaking of, subscribe to the podcast on your favorite podcast platform. Wherever you listen to Bean to Barstool, go there and subscribe to make sure you get notifications of new episodes. If you're a proud millennial like me and you still use an RSS feeder, you can also subscribe to our blog posts, which come out at least weekly. Also, if you are still on social media but don't love Meta right now, you can check me out over on Blue Sky. I'm on there under my personal account at David Nilsson Beer, but I do post all the Bean to Barstool content over there as well. Finally, if you want to get in touch with me directly, you can email beantobarstool@gmail.com. I am not leaving Instagram anytime soon, but these are great ways to make sure you can keep up with what I have going on. Stay safe and take care of each other. Let's change paths and go back to talking about fermentation a little bit. How do these details you're talking about with the microbiome impact what we're seeing in the fermentation space as we lose diversity of microorganisms in the soil and therefore in the plants that are growing for them? How does that translate into fermentation? I know you've expressed that farmers or whoever is doing fermenting is always asking, like, for exact times that they, is it this many days or what? Like, how is this actually playing out on the fermentation side?
Okay, so based on my experiences, both working with farmers and then the experiments, the observational experiments that I've been running over many years, paying attention to especially the sensory indicators has been a big one, okay? And then paying attention to published and unpublished research that I'm privy to. It is very, very clear that the mechanisms we may not be able to fully understand and explain now, but it is abundantly evident that as long as that diversity for a given space, that healthy diversity, because you can have the diversity, but it may not be healthy. That diversity, actually, based on what we understand about cacao fermentation and fermentation dynamics in the cacao space, you have your broad groups represented: your yeasts, your bacteria, which will include your lactic acid bacteria, your acetic acid bacteria, okay? And they're named after those, but they're not the only acids that they're going to be producing. Like other organisms, like every other organism, there are many other products, metabolic products that are being produced in the system. But for simplicity's sake, when we talk about fermentation and we try to share what we know, we go for the broad strokes, okay? Your yeasts, and especially your yeasts that are working on the available fermentable sugars, converting that sugar, those sugars into alcohol. and that alcohol being the primary, not the only, but the primary substrate that we're going to focus on, that the acetic acid bacteria need for their quote unquote work, for their existence. They're using that that alcohol and converting it into acetic acid, which has been shown to be like the key in the ignition for the internal chemical and biochemical reactions taking place in the cotyledons of the cacao seed, right? So I will use this opportunity to say that, as I say ad nauseum during working, sessions with farmers and chocolate makers, if we do not do a really good job on the outside with the actual fermentation of the pulp, we cannot create basically the required elements for doing a great job on the inside with the cotyledons. Because what has been found is that the acetic acid, unlike other acids, because they've tried this with other acids, the acetic acid seems to be, there's something, I have not yet seen if the research has spoken to why the acetic acid is so unique and important as a trigger for that, for the internal biochemical processes. But it's been shown that the acetic acid is crucial to that process. And what happens is, based on current understanding, the rising heat that is produced as part of the process, it's an exothermic or heat producing process, that phase with the acetic acid bacteria. As the acetic acid is made, the temperature jumps tremendously. In a well-run ferment, I can go from first phase, yeast-dominated, sugar-consuming phase, sugar consumption phase of the yeast. You can go from, let's say, a temperature of 35 degrees Celsius, whatever that is in Fahrenheit. My brain just does not function in that dimension. Let's say 35 degrees Celsius. I can get a clear, clean 10-degree jump to 45 degrees Celsius once I aerate that mass, when it's ready to be aerated, and that readiness is signaled by the system. It's not me deciding it's time to turn because I have to go to that barbecue this afternoon. We're going to turn you now. No. You make decisions, you make informed decisions and actions on your system based on what the system indicators are telling you, i.e., the microbial activity shows certain things in the physical realm at the level of aroma, at the level of texture of the pulp, at the level of temperature changes, okay, and the profiles of those temperature changes, okay, at the level of color changes as well, both external and internal to the seed, okay? So I tend to use a suite of skills like many others in the space. Some people will also be avidly following the pH changes of the pulp and the tester, so the seed coat, relative to the pH of the cotyledons. And it has chemical merit because the pH is tied to the ability of the enzymes to work, to break apart what we call the stored substances or the food reserves that were laid down by the mother for the young cacao if you planted out that seed, right? And these storage substances include your proteins, your complex sugars, okay? You have your fats that need to be released. The fats are normally not broken down in a well-run ferment. It's only if you go into over-fermentation and then other organisms begin to dominate the mass together with the enzymes and other enzymes that exist, the lipases that exist in the cacao seed. If you go into over-fermentation, okay, as in those biochemical reactions are allowed to continue on the inside because of excess, well, not excess, but free moisture, free water availability, those enzymes still have a medium in which to continue functioning. And this can happen both within your fermentation system. It can also happen during your drying phase. So this is no longer about fermentation per se. It's about water availability inside the seed that allow the enzymes that break fat down to continue working. This is why drying now is also a science. Fast yet slow, but that's a whole other conversation, right? Yeah. But the point is, with the acetic acid and the pH changes inside the seed, the rapid drop in pH triggers a first round of enzymes that need to work on the proteins, okay? Because the proteins need to be broken into specific things to allow the actual accumulation of the right quantities and proportions of your flavor precursors.
I want to stop you and ask a couple questions here.
Yeah.
If we were looking at a completely wild population of cacao, no human intervention, it's just growing in the forest somewhere, how is it getting to the point of a seed germinating? What is happening if this were actually going to be able to seed a new cacao tree?
Okay, great question. Cacao is not one of those fruits that falls from the tree. It will remain on the tree. You don't harvest it. It's going to remain on the tree. The tree is going to extract the nutrients that's left in that fruit, repurpose those nutrients, and the pod itself, pod, seed, everything is going to decompose on the tree. You're left with a shadow of a pod that has gone black, and it's literally decomposing on the tree. And then the stalk is going to fall off, okay? Cacao is also not a fruit that explodes when the seeds are ready to be, when the seeds are at what we call ripe or mature stage, unlike some other fruits, okay? So for cacao seeds to get out of that pod and taken anywhere else, it has to happen by animals, whether it's humans or our friends of the forest, your monkeys, well, your rodent family, in your more cultivated systems, your squirrels, okay? So I actually should share a photograph with you yesterday. We had massive evidence of rats having attacked the pods on the trees, sometimes on very, very precarious branches, right? But they've gone after the pulp. And of course, the seed is too bitter and astringent. They're not interested in the seed. So the seeds get dropped right where they've cracked open and they've feasted. In some cases, it may be even a little further from the tree because they've managed to, eat and walk, eat and run, but it's not going to be dispersed very far. So there has to be animal/human intervention for these seeds to be moved well beyond where the parent plant is. Okay. But let's say, as I saw yesterday, and I've seen many times before, the seed falls after the pulp being consumed from the fruit on the tree, and it begins to put out root, okay? Now, because the animal has managed to eat off most of the pulp and it's now exposed, the pulp is going to start drying. Whatever residual pulp is there, it's going to start drying, okay? And as the pulp quantity is reduced on the seed gets a signal to start germinating because the pulp in cacao has what we call germination inhibitors. It's not going to germinate if the pulp and the pulp components to inhibit are still there, okay? So in natural systems, the pulp will be eaten off, decomposed, etc., because it's falling onto the ground. It's going to be exposed to microorganisms that are going to start digesting, just like in a fermenting system, right? It's just not controlled, okay?
But you're saying it's drying, so it's not being fermented off. I mean, the pulp is just drying rather than there being a fermentation process.
No, it's a combination. It's not one or the other.
Okay.
As long as that pulp is exposed to the air, it triggers the activity of the microorganisms.
And with that being, the reason I'm asking this, what I'm trying to get to understand for myself, when we're doing a cacao fermentation, you've got a large biomass.
Yes.
And you've got a lot of pulp, you've got a lot of sugar present, you've got a lot of moisture. When we're talking about a animal that has eaten this fruit and then taken off and dropped a single seed somewhere, you don't have that same mass. So are you getting that same sequence of alcoholic fermentation followed by aerobic acetic, fermentation and all this stuff? Are we actually mimicking the same thing, or is this a very different process?
Okay, so think of it this way. The fermentation, the organisms that are going to be digesting that pulp, consuming the sugars, converting into different things, this is happening at a micro level. When we have a mass, we're actually turning up the volume on and also the visibility, the intensity of the aromas that we can actually see and smell, right? So it's a lot more concentrated. So the impacts, the effects are a lot more evident. It's like composting. When we bring elements together, okay, and we create this intentional compost heap that we want to run in a thermophilic way, a hot compost, right? Nature doesn't do hot composting, but stuff gets broken down anyway because of the activity of microorganisms, and it helps to create all of these organic compounds like your humus, your humic and your fulvic acids, right? But it's not doing it through all of this heat expression, okay? Because the mass is not there. When we create an intentional fermentation heap, it can even be a handful of beans, but if those beans are well inoculated, you can get that temperature up to 50 degrees Celsius. Been there, done that, okay? So that's why they refer to it as the mass effect. The more you have in terms of food in the form of the pulp, right? The more of the seeds, we're assuming we're bringing in a corresponding increased mass of microorganisms to work on that material. But it all depends on how those beans have been handled. So there have been some locations where I've seen they've diligently, in an attempt to control, to keep high quality, they will wash the pods before they actually open them to extract, right? Because consumers, whatever they're seeing, they're like, but wait a minute, this is not very hygienic. If you're telling me cacao is a food and you're extracting it on this farm in the jungle, right, where you have all manner of soil elements, because we've equated the bush, the jungle, with all manner of dangerous things, right? Everybody gets labeled as bad. No. We have food safety rules. You need to make sure that you're handling this with, these latex gloves. We don't know where the latex gloves have been, okay? We need to have these food grade buckets, and we keep increasing and increasing all of these regulations. And I'm not saying no to the regulations, but regulations need to be applied to context, right? Yes, this is an agricultural crop, an agricultural food, okay? But there are limits because we actually want to harvest the microorganisms from that environment, okay? So coming back to your question, in a, let's say, a one pod situation, for example, if a bird decides it needs to fish for the worms and whatever insects that'll come, it'll puncture the pod and allow the air to get in. The signal goes out with the aromas and everything else. The creepy crawlies start to enter the pod because they're there to be a part of the buffet. The bird returns to start feeding on whatever is there. Then the squirrel or the rat gets wind of, oh, this smells yummy. I'm on my way. So then the rat makes an even bigger hole, okay? But the pod is still connected to the tree, and the placenta with the seeds, they're there. David, I have discovered I've come across some of the most incredible in-pod on-tree ferments I have ever seen, okay? It will not, again, because of the mass and how it's not being handled in that pod, it's obviously not going to develop the heat that we would have in, let's say, a closed fermented system, right? But the alcoholic phase happens. It happens beautifully. And I have had some of the most amazing alcoholic smells come off of those, in-pod suspended ferments, right? But yes, you're quite right. We're not going to have the same heat buildup, but it doesn't mean that the fermentation products are not there.
And that makes more sense, because as you're describing the sequence of chemical processes that are happening, there has to be a natural reason for them to happen. They have to do something, even though that's not what we're necessarily using them for. And so as you're describing quote unquote controlled fermentation, acetic acid getting in, triggering these enzymes that are going to break down all these different things, I was just curious how we see that mimicked in a completely non-intervention natural space.
You will definitely get the alcoholic part of it, but based on what we understand now with what happens inside the seed, you have to create a more closed, protected environment for that heat to build, to effectively trigger the reactions on the inside. This is why I said earlier, a box is not a box is not a box. Because sometimes I've worked with certain fermentation systems where they've literally just constructed a four-walled floored wooden floor vessel that is not properly designed to manage what goes into that box. And it goes through what happens in the natural environment, almost nothing, because there's massive heat loss. The organisms cannot fully establish themselves to do what needs to be done in that closed, those closed quarters and, managed quarters. It's a very, very different dynamic. But I will tell you, from tasting things across the field, when I see certain things happening, the fermentation products are there. You're just not going to see you're not going to see the temperature spike, etc. This is why when fermentations are done like in heaps in the field, that heap creates a particular enabling environment that wouldn't normally happen if we just left the beans lying on banana leaves in nice thin layers. Yeah. Mm-hmm. It's not going to happen in the same way. You will get an end product, but that end product is not going to unlock the flavor precursors that we're after. So it's, this is where so many of us in the industry, if not all, who work with cacao, we really wonder who was the first to actually realize that this thing needed to be fermented this way. Was it accidental? Did they throw a bunch of beans, that nobody was using? They just left it in a heap and they started realizing that, I don't know, or did, as you have with many of these indigenous cultures, a lot of these kinds of modifications, it's revealed to them, right? Because of their connections to the plants. There are things that either came to them in dreams or visions or whatever. I would love to go back in time to actually see where this first started. But of course, here we are. I don't know if in another dimension it'll happen, but it's always interesting to know. So who was the first? Who was the first guinea pig to know that this actually tastes good?
We see something similar on the brewing side, not so much in the fermentation stage as in the saccharification stage during mashing at the beginning, where we are massively accelerating natural biological processes by increasing heat. So do you know much about malting or mashing?
No, so give me a quick tutorial. This is great.
Malting, we're taking a grain, typically barley, and tricking it into germinating through a cycle of water saturation and then drying it back out. And we're doing this and, kicking off plant hormones that trigger the development of enzymes. And then we dry it back out very rapidly to freeze the process in place. So we've got now this barley seed that is fully prepared to grow a new barley plant, but we've stripped it of moisture, and so it's just frozen in stasis. Then when we actually get to the brewing process, the first stage of brewing, grind up those barley kernels, mix it with water, and heat it up to about 150 degrees Fahrenheit within a couple degrees, and those couple degrees can make a big difference based on how much sugar we want to create. But we leave it there for about an hour, and at that increased temperature, all those enzymes kick into hyperdrive. So alpha and beta amylase are breaking down all of your starches into simple sugars, and adjusting that temperature just a couple degrees Fahrenheit will determine whether alpha or beta amylase is more active, and so how much sugar you're creating. And then you're draining it off of the grains and boiling it and sending it on to the rest of the process. But that process, basically what you're doing is simulating what the grain would be doing if it fell into the soil, but what would take weeks, you're doing in the space of a very, very short period of time by increasing temperature. So it's not the same thing. We're not talking about fermentation, but it is a similar process to what you're talking about in terms of the application of heat, rapidly accelerating those natural processes.
Precisely. So this is where now actually, oh my goodness, you just lit a fire in my brain there with that mention of that germinate and freeze. So you've triggered certain things on the inside that will, it's going to shift. If I'm thinking from the cocoa perspective, right? Usually we recommend it's always recommended to farmers that you don't use germinated seeds in your fermentation process for physical and then sensory based reasons, right? Physical being that once the seeds have started to germinate, as in the pod, you are going to end up with a very sprouted taste in the chocolate. It's very interesting. I wish I could make you a bar of just sprouted chocolate, cacao seed chocolate, right?
What does that mean? Does it just taste planty, just green?
Yeah, it just tastes like, when you do sprouts, so like
Uh-huh.
pumpkin sprouts, it tastes
Yeah.
like that, but
Okay.
in chocolate.
Sure.
So unless that's your jam, it's not really what people are, at least fine chocolate is after, right? But I keep wondering, what else is being unlocked now that you've helped me, you've brought this back into my line of sight and hearing. What else is being liberated, right? That we could probably tap into, not necessarily for eating chocolate, but something that actually contributes to another kind of cocoa-based product that has additional health benefits or just ongoing health benefits, right? I'm just very curious about the profiles that could be unlocked there, especially given what happens with lavado, right?
Mm-hmm.
When I
Yeah.
work with lavado. So you can have lavado as in straight out of the pod, wash the pulp to get some of the pulp off. Again, very varietal dependent, because some varieties have pulp that really structurally, it refuses to come loose with just water. And then there are others that are much softer that you can do a wash and you can actually remove a considerable percentage of it. But the idea is to get rid of the sugars so that you remove and reduce all possibility of any kind of fermentation product being developed while it's drying, okay? So while it's drying, from that fresh scenario, straight out of the pod, I wash to get the sugars off so that when I put it to dry, I don't have to worry about scandalous mold or any other organism taking root in that pulp, because there's nothing to eat unless you really want, structural components. I can shut you down in terms of microbial activity, right? So that I can dry you, and then I'm just after what's on the inside. But I started thinking about the wet fermentation methods for coffee and started experimenting with that. So different water-soaked methods, right? Going off of what I noticed farmers were doing, just as part of their not planned schedule. I just want to get this pulp off, and I realize if I leave it for 2 to 3 days in a bucket or bag that allows drainage, it goes through that pulp fermentation, yes, but we're not taking it through a hot fermented cycle to now trigger certain things on the inside.
Mm-hmm.
So the industry would generally class that as under-fermented or unfermented. And there are iterations of it that would be considered like Sanchez in the Dominican Republic, right? They've given it that name. But at the end of the day, it's not gone through a well-fermented, controlled hot process to trigger the reactions on the inside that then give us a different kind of flavor profile. But if we're not interested in going after high-end chocolate, eating chocolate, but we're after this as an ingredient in something else, as part of a beverage, then the conversation on the landscape changes as far as I'm concerned with respect to processing, right? And this is where lavado caught my attention so intensely, and it continues to do so, because more and more I'm seeing on the circuit that people are starting to pay attention to what can happen with lavado for beverages, right? The health benefits coming out of the use of lavado in beverages or integration as an ingredient in a larger recipe. I'm quite fascinated by it because it gives farmers a chance to work with smaller quantities of beans. Okay, let's say you're at the end of your harvest, you don't have the required, according to, based on what you can work with, what gives you a well-run hot ferment, you don't have the required volume, and you really don't have the time and energy, and you cannot sell that small volume to a buyer if you're selling your beans, right? What are you going to do? You prefer not to leave the pods on the trees. It's better that you not leave the pods on the trees from a physiological point of view with the tree itself, okay? But you recognize that what am I going to do with these beans? I can't run a good hot ferment. Do I just let it go to waste? No, we have an opportunity to create a value-added product here, even if it's just for personal consumption, right? So lavado in that sense has caught my attention. And now that you've planted this seed in my mind regarding, wait a minute, what are we not looking at with respect to what other flavor profiles can we bring out of this that can be leveraged in another type of product, beverage or otherwise, right?
Mm.
So stay tuned. because I'm going to go down that road. Yes, it's going to give me a chance to work with micro quantities, because if we're talking about germinating, we freeze it, and then I do some further work on it. Oh my goodness, I'm ready. And this is something that you and I can look into because I have small enough quantities to do this.
Yeah.
Yes. So, yeah. So thanks
Another
for
thing we
that.
still need to do, and you and I have been talking about this for a year and a half at least, is pitched fermentations of cacao with brewing cultures. And I'm
Yes.
still so excited to
Yeah,
try
yeah.
to do
And
this.
so you wanna remind me a bit, or well, help our listeners understand why this is of particular interest to you, like keyword thiols.
Yeah, well, that's one of them. I mean,
Let's go there.
so you were talking earlier about fermentation temperature. You were during the alcoholic phase, you were saying 35 degrees Celsius. That's about 95 Fahrenheit.
Hmm.
Looking at Saccharomyces cerevisiae, which is our ale fermentation species, there are tons and tons of different strains within that. Most of them in a brewing environment where we are going to be keeping whatever fermentation products come from that, 95 degrees Fahrenheit is unmanageable for all but a handful of strains. Most of them are going to create flavors that are very, very unpleasant. Now, that might not necessarily be true, of course, on the cacao side, because we're not necessarily keeping all of those fermentation products directly. We're getting this fermentation, and then all sorts of other things are happening.
Yes, sure.
So one of the first things I want to see is working with some ale strains, Saccharomyces cerevisiae, different strains in a cacao environment, to see if and what fermentation flavors actually impact the finished chocolate. There are some strains that ferment at those temperatures in beer. So, like some Belgian Saison strains will ferment up in the 90s Fahrenheit and do fine. Really excitingly, though, there are some cultures coming out of Norway called Kveik, which are farmhouse strains that have been used for centuries, that can ferment up above 100 degrees Fahrenheit. So, with your 40, 45 degrees Celsius that you were talking about, like, it can ferment cleanly at those temperatures and produce some like tropical fruit type flavors without any off flavors. The next thing we've talked about, though, is this issue of thiols, and you would be able to explain just at the biological level what those actually are. But there's been a lot of attention on thiols in brewing over the last 5 to 10 years, coming from hops. So hops are the primary seasoning in beer. They provide both bitterness as well as flavor and aroma, and how you use them is going to determine whether you get one or the other. And what variety of hops you use is going to determine what those flavors and aromas are going to be. There are lots of flavor active, aroma active compounds in hops that we've known about for a very long time. Thiols are one thing that we've started to study in the last 5 to 10 years. Thiols are a group of compounds that can be not flavor active in one state, bound thiols, where they're attached to another molecule and they have absolutely no aroma impact. But if they are cleaved off from that molecule they're attached to, they become free thiols and they become very aroma active. And so we've started looking at ways to free those thiols and get even more aroma and flavor from our hops. One thing that's happened just in the last few years is the bioengineering of yeast strains that can break off those thiols. They're called thiolized yeasts. And so you and I had started talking about this, about whether or not these compounds exist in cacao, and whether or not the use of these new yeast strains would be able to create a change in the flavor profile of the chocolate that we're making from a cacao, if we were to use that in that fermentation space.
No, it's really, really fascinating what you say. And I like these clear parallels that continue to emerge. The thing is, with these thiols, they're the specifically volatile sulfur compounds. They're super important in cacao because they're really, really important for actual chocolate flavor, right? The little that I understand about the chemistry, it's really, really basic. But ever since you mentioned it to me, I've been starting to go down that other rabbit hole because they are so, so important for chocolate flavor formation, right? And the thing is, there are lots of them in cacao, but we've not been able to identify a lot of them because of I guess the tools. We have to draw on tools that are being used in other industries like in beer and brewing to really see how those can be applied to cacao. There was some work done. I think I shared that publication with you that started looking into some compounds that were identified, but there were so many and there were not enough of they didn't know what they were, so you can't even have standards for what you don't know to be able to quantify what's there, right? But it is my hope, and I'm going to make a shameless call out here. It is my hope that Penn State University is going to be able to help me realize at least some preliminary research in that regard, because they are doing work like so many others on, what's been happening with wine and beer. Okay. And these styles that you mentioned, the work that I've done with them, looking at cacao fermentations and how, the fermentation dynamics and the basically using a backslopping method to reintroduce a highly activated version of the original microorganisms from the runoff. How can that affect flavor? And it is very clear that it is affecting flavor in multiple dimensions, with respect to the expression of certain compounds versus others, the rate at which these compounds are formed in that re-inoculated, that backslopped mass versus allowing the system to run naturally. Yeah, it's creating the desired end products much faster, let's say, and based on the published research that we have, we're seeing that it can shave off almost a day or two of your fermentation work, and it's giving you roughly the same endpoint. Now, of course, that was just very preliminary data coming off of work experiments that I ran in 2019. I've been doing a lot of modifications since then, and you and I have spoken, off the record about that. Again, because I have major problems getting the required mass to run the ferments that I would like to ferment, I've not been able to take it any further on my own on the farm itself, but I have been using other locations to test that backslopping method. And with respect to using these, these yeast strains that you're talking about from brewing, I am beyond excited to actually just sink my hands into that kind of work, because I think it's going to open some really, really fascinating doors for us. The concern that I have, the interested concern that I have is when it comes to these microorganisms, okay, the letting them loose in the system has consequences. As long as you change the players in the matrix, you change one, you shift the entire matrix, because these organisms function based on quorum sensing. They will do or not do based on population numbers, based on vigor of those population numbers. So it's going to be very intriguing to see, smell, taste, hear in some cases, what those organisms are doing in a fermentation mass, given that I'm not trying to overpower the rest of the microbiome, the zoo that is in that fermentation mass. Are these yeasts going to play well with the natural yeasts? I don't know. We won't know until we try. And I'm prepared to experiment with that and have quite a few of my friends be guinea pigs for the end product. But it can't be any worse than the aggressive, under-fermented hell in a spoon versions that I've been dishing out to them, right? So God bless my friends and colleagues who are willing to, be on the sensory end of all of this. But the only way we're going to know, David, is to try. What I can say, there are two things. I have a comment, and then I have a question for you from the beer side of things, since I'm not familiar with that terrain, right? Let me ask a question first. In fermentation with beer, are we looking at a complete dominance of these yeast strains? The yeast are the only things you guys are really interested in for beer fermentation, or are we looking at background supporting actors producing other compounds in the space that add to the dimensions, the flavor
So
dimensions of the beer.
for 99 point some high decimal of all beer produced, ranging from small craft breweries all the way up to macro producers, you're looking at a single culture. So we are controlling our sugar content from the mash. Then we are sterilizing that in a boil. Then we are pitching not only the exact strain we want, but the cell count we want. And then we're controlling the temperature of that fermentation. That is the vast majority of beer. There are exceptions, very small batch exceptions, some that are historical styles, some that are, just experiments where you are using either a completely spontaneous fermentation from the environment, in which case you're getting a zoo, as you've described it, or a pitched mixed culture of yeast and bacteria. Those exist. You can find them. They're not, I wouldn't say they're rare. They're just very small batch. And so it's kind of, it's not exactly analogous, but it's similar to like natural wine versus more traditional wine.
That's what I thought.
But the overwhelming majority of commercial beer is pitched single culture.
Okay. Well, then it means these experiments are going to be wildly fascinating, David, and you need to be the first to taste the results.
I can't wait.
Given that you planted this seed, I hope you're prepared for what you're unleashing, because we're talking about, with cacao, this is where the parallels stop. It's massive divergence from now on, because with wild or spontaneous ferments, I do not know what is in there. I am quantifying nothing. There's no cell count possibility from my end. Nice academic exercise, but I can tell you who the broad groups are going to be in there, right? But in the end, it is a full-blown zoo. And my desire is, based on the understanding of fermentation, wild fermentation science, I want as many to that party in that zoo as possible, because it's going to bring redundancy that is super important for if strain A of Saccharomyces cerevisiae for some reason is suddenly uncomfortable in the quarters because the pH temperature, some other organisms are producing some compounds that have really shut it down. Strain C, D, and E can now carry the weight until strain A can come back into play. And the research has actually shown that during cacao fermentations, there are different strains of the yeast that basically play different roles at different times in that phase one. So we're talking about a level of complexity within complexity that oh my goodness, I wish, honestly, David, I wish
Are there other major, specifically looking at yeast, other major yeast players besides Sac-C in cacao fermentation?
Oh yeah, for sure. But what the literature has shown, at least based on where they've been doing their sampling, etc., because remember, all of the research is tied to the context under which the research is done, right? The Sac-C has been the most dominant, most ubiquitous. Let's just say that, based on what I've read coming up through historical research, Sac-C, but you definitely have others. But Saccharomyces cerevisiae has been the star of the show. But then it comes down to all the different strains that are in that space.
Right.
Yeah. And
I think probably our closest analogy is going to be lambic production, which is a Belgian style. I believe I sent you a while ago a paper that had been done, a study on fermentation within lambic, and specifically the various fermentation arcs of all of the fermenting species within that, because it's completely spontaneous, completely ambient. And so you get significant Sac-C fermentation early on, then you get longer term fermentation from various bacterias, Brettanomyces, much slower acting yeast genus. And that production of lambic is a minimum of 6 months, but can be several years,
Wow.
as you get these different things active for a long time. So the way it's produced, you do a typical, you do all of your initial steps like you would with any other kind of beer. Then it gets
Hmm.
dumped into this wide open metal vessel called a cool ship. And for a long time, the romance around lambic has been that uh, cooling off in this open vessel, it was collecting microorganisms from the air. And
Yes, you did
certainly it's
say.
grabbing some.
Yeah.
But what we're seeing now primarily is that after that, it's sent into wooden barrels. Most of these cultures are just existing in the wooden barrels. And so we're
Yes.
creating a micro ecosystem in this
Yes, you
barrel. And
are.
that's what's actually really inoculating the wort.
Precisely.
Still,
Precisely.
it still traditionally gets cooled in this open vessel. And it is an efficient way to cool it without mechanical intervention.
Gotcha.
But most likely it's just all resident in the oak.
Mm-hmm.
And there's a
Mm-hmm.
lot of mythology around this of brewers, not over cleaning their cool ship room because don't want to disturb what's in there, and like
Yes.
leaving these windows open in that room to get outside airflow and
Mm-hmm. Mm-hmm.
all these
Mm-hmm.
different things. And it might be contributing something, but it's in the oak.
It's it's in the oak, but the oak is working together with whatever that microclimate is also creating because
Sure.
you're talking about think about it think about it like your skin, right? You have the outer layer that has its own microbiome. And then as you start to move in, you have different layers of microorganisms that are inhabiting that space and communicating with the biome in the body. Okay? It's the same thing on the fruit. Let's bring it home to cacao. You have the microbiome, as I said at the very beginning, you have the microorganisms that are on the fruit and they're in the fruit. Okay. So, whereas before we thought that, and the literature spoke to the fact that inside the pod, as long as the pod is not, if it's once it's unbroken, the fermentation is not going to start, and that the inside of the pod is sterile. Yeah, that needs to be completely erased from the whiteboard. Nothing is sterile. We have not been looking for it and we did not know. But now that there have been all of these microbiome studies across different layers of of organisms, nothing is sterile. It's all the way down into the pod. Okay. It just may not be activated until there are certain environmental triggers, right? So coming back to the beer fermentation scenario, I actually wanted to ask you to walk me through the aroma changes as beer is being fermented. Okay? Because I want to understand like what kind of transitions are we talking about? How subtle, how dramatic are these things used as indicators as well in
Mm,
beer production, as maybe not on the level as cacao, but it'll be really good to understand
yeah.
the other indicators that are used with beer.
I would say that the sensory inputs are significant, or the sensory cues are not used nearly as much on the
Okay.
beer side as much as attenuation. So looking at how much
Mm,
of the sugar is actually fermented. And those
gotcha.
are the cues we're looking at is have we reached the attenuation level that we're looking for? And then now, and this is for sensory purposes, but at a commercial level, it's usually not actually going to be using our senses to evaluate this, but there can
Mm.
be some additional time added at the end of fermentation for the purpose of allowing yeast to reabsorb some of its own fermentation products, namely
Oh,
diacetyl and acetaldehyde. Uh,
fascinating.
and again, depending on the brewery, depending on the controls that they've had up to this point, that may or may not be necessary. There are some yeasts that are being developed that don't produce those in the first place, but
Yeah.
something like a diacetyl rest at the end of fermentation, where temperature, particularly with lager fermentations that are at a cooler temperature to begin with, you might step up the temperature of your beer and allow it to sit for an additional 24 or 48 hours to allow the yeast to reabsorb some of its fermentation products that would be unpleasant from a sensory standpoint in the finished beer. But that is mostly done at this point predictably on time and temperature
Time and
rather
temperature.
than actually being tested. Now you could physically test for that, and at a very small small commercial production level or at the home brewing
Hmm.
level, that could certainly be a taste test and say, yeah, this
Yeah.
actually does need a little bit longer. But most of the actual at a commercial level, even a very small commercial level, that's going to be done based on attenuation level and confirming that you've actually fermented
Mm.
the sugar that you want to ferment. Because if that's done and you get to the target you want, because you have controlled the culture, then everything else is kind of pretty predictable around that. If you've reached how much fermentation has
Yeah.
occurred, you can pretty predictably say, then we know that we're going to have the flavors that we want.
That's awesome. And I can tell you now, that's exactly what the chocolate world wants. And it's what the chocolate world cannot
Yeah,
get
it can never, it
right
will never
now.
happen. Yeah.
Okay, I usually try to never say never because the universe always shows, okay, hold that bear. I have something to show you,
Sure.
right? But there are so, as you already recognize, and you're helping all of us to unpack, there's so many layers, so many contributing factors and then variables within those factors influencing how anything happens in cacao. It's like, where do you even begin to control,
Right,
right?
right.
So for example, at the workshops that I ran in Grenada, there was a gentleman who asked, so isn't there a more precise way to do this? Because many people are actually floored by how rudimentary, how very rustic. In some cases, some people are actually, and these are usually consumers who are just into eating the chocolate and they don't know the process at all. They're like, why is this so primitive? Why is this still so primitive, right? And you'd have them and everybody in between, all the way to the engineers who are not thinking about this system as a biological one. They engineer the equipment, the stainless steel tanks, because they're just using beer and wine as their reference points.
Mhm.
Oh, but we can control this, and we can have all of the fancy lights and bells and whistles to tell these organisms what to do where we want them to do it. But cacao does not allow that. It resists at every turn. And for example, I've seen some unpublished in research, at least not yet published, because they're in the process of going through a whole bunch of iterations with respect to the the strains that they've isolated to put into these fermentation tanks, right? So they would go after, okay, so who's dominant? They must be doing the heaviest lifting, okay? And I'm not saying no, but they may be doing the heaviest lifting, but are they having the highest flavor impact? Because one of the things that we've recognized in chocolate, in cacao, you can have very, very small quantities of very powerful flavor molecules. And they're the ones that will dominate or at least show up in your taste, your flavor perception of things, but they're not necessarily there in the largest quantities.
Yeah.
So for me, it isn't a case of who's most dominant. It's who is playing together.
Well, and that's really one of the fascinating things, and we see this a lot with hop compounds, is that you can break it down to these individual flavor components and say this will come across like this. But
Mhm.
when they're in conjunction, that is not always a clean algebraic formula of this is orange and this is grapefruit. So together they're orange grapefruit. It can be something like in combination now it's raspberry. Like it's so unpredictable.
Listen, it's wildly wonderful. Yes, you can get some rude shocks, right? And I can tell you now, you see, with these experiments that you and I have planned, I welcome the rude shocks
Oh yeah.
because they will
Mm.
help us understand. It's how it helped me understand how to navigate well-run cacao fermentations. It's not about getting it perfect right out of the starting blocks. It really is about the process. It's about the journey, right? Because it may springboard to other things, and then we can still carry on with, okay, how do we produce a nice, flavorful, actually tasty, useful product, Sarah? You know what I
Yeah.
mean? But I do want to make a comment, circle back, because it finally circled back in my brain. When you made the mention of with the lambic
Hmm.
beers, right?
Yeah.
And the mythology around do this, don't do that, and the washing of the barrels or not washing the barrels. Tell me something about for those who do wash the barrels, what kind of frequency and what kind of wash are we talking about? Because I want to draw a parallel with what happens in cacao, because it's a firestorm discussion in the space, both smallholder and large. Why should we do this? No, some experts say don't do it. Use this, don't use that. Some people encourage absolutely filthy boxes under the guise of, or the understanding of, we need the organisms there, don't wash your boxes. And I'm like, we do need the organisms, we just don't need those organisms, because those organisms are creating some funk that we don't need in the chocolate. They're creating problems for drying because you're carrying over a whole bunch of molds that we
Right.
do not need. The work becomes even harder for the farmer now, or the processor, when you're carrying this whole other crazy zoo that has manifested itself at the end of the fermentation. You're struggling to dry under humid climates in many cases, right? Like, where does the fight end for farmers? How can we actually
Right.
make this, again, we're coming back to, and I say this to farmers all the time, our job is not to jump through the hoops that the consumer has decided he or she needs to set because they don't understand how this works. They know what they want, but they don't know how we get there or how we can't get there, right? Our job as farmers and processors is to ensure that this is food safe, that it is palatable. Well, beyond palatable, it's actually enjoyable, and that it gets to destination the way you packaged it to get to destination, so that quality is maintained from tree all the way to final saleable seed, and you can be paid for your worth with the work that has gone into all of this, right? It needs to be fair play, or else game over. But when we have very divergent opinions that are not shared with context as to why they're making these recommendations, farmers are caught in the crossfire of, who should I believe? Who should I listen to? Who has more credentials after their name that I can say, no, this professor must know what he's talking about? Is this professor on the ground with you to understand your location-specific context that may actually need some modification with respect to the protocols on your handling of this? In many cases, no. So farmers, the first question that always comes out when I start dealing with fermentation training. So should I wash my boxes or should I not? How often should I? How much mold is okay? How much mold is not okay? And then I say, okay, now we're ready to have this conversation. And I go into the fact that, what are we starting with? What are we working towards? What is the desired end product? Let's work backwards now. The organisms that are dominating the mass at the end of the ferment are not the ones at the start of the ferment.
Right.
And especially if we happen to, not happen to, because these things don't just happen. Things are put in play and we have consequences based on our actions, right? So if we allow the fermentation residue to remain in that space, and there isn't quick turnover of your ferments to keep introducing fresh pulp, so that the populations, the diversity and the richness of the species that are present there, they're maintained at a particular level, okay? To say, okay, we're renewing. Yes, great. I don't need to clean my boxes as frequently during peak season, because every time a batch comes out, another batch goes in. If, however, I am fermenting now and my next batch is going to be in 2 months, do you know what's going to grow on that
Right.
residue?
Yeah, sure.
It's a completely different dynamic. It's a different set of people. Well, it's a different set of things that are feeding off of that buffet, right? Because now the food that's available, the conditions that are available are completely different. Yes, the yeast, etc., may be there, but when you bring fresh, clean, edible, nice, pulpy, sweet, tart beans, and you put them into this box that looks like it should be in a compost heap, I have a problem, because we're saying that this is a food right out of the fruit, and then we're putting it into very toxic environments. And the thing is, when you have, because of what we understand now with microbial dynamics, when you have organisms, especially disease-causing organisms that dominate a space, when you have the good guys and girls brought in, there's going to be some friction, for want of a better word in microbial terms. There's going to be some aggression. And when there's aggression, organisms, microbes produce compounds to defend themselves. And many times those compounds tend to be very bitter, okay? Or in some cases, because I don't understand or know all of the science, right? But I am suspecting also This is where a lot of the weird acids are coming from. Okay. So coming back to what I started to mention a little while ago, where, there's currently some unpublished research, some trials going on with respect to, they want to develop commercial cultures, right, for the large operations that they have. They're recognizing having isolated yeast 1, lactic acid 2, and acetic acid 3, right, in terms of bacteria, and putting them together. Like you said, it's not a simple algebraic equation. They're recognizing that some of the acids being produced in these ferments are so ghastly that they're stunned, because we've gone in, not we, the folks who are doing this, they're like, wait, they're going in expecting great stuff right out of the blocks, but not holding space for the fact that just because you put us together doesn't mean we're going to play well together. Yeah?
Yeah.
And this is why I always say to farmers and processors, our focus needs to be on who is actually doing the work. What do they need? And how can we facilitate that? Because all we're doing with fermentation systems is creating an enabling environment so that everybody can play well together, so that we don't have the drums and the flutes screaming on one end and the rest of the orchestra, well, nobody knows what's happening with the rest of the music
Right.
piece is a disaster, okay? So we can't have that kind of symphony in the system, the microbes. If we're not doing what we need to do, then we can't inherit the symphony of flavors and the balance of flavors that we're expecting on the other end. Garbage in is garbage out. And it does not only refer to putting in infected beans into a fermentation mass and expecting to get high quality out on the end.
Yeah.
It starts with the mindset of the producers and the processors. And then at every point in this process, we need to inform ourselves and then take the relevant actions to maintain that quality control now that allows us to have a higher probability of a good end result. And it's the consistent practice of that then leads to a consistent endpoint. But the flavor is never going to be exactly the same, because nothing in that system is exactly the same.
One of the beautiful things about agricultural products is also one of the potentially frustrating things for growers and producers. They're never going to be exactly the same from one place to another, from one year to another. For those of us who love tasting craft chocolate, that means we have to lean into and accept those changes and that variability and celebrate the fact that we are tasting something that came from the soil, from the hands of farmers. I want to quickly clarify a few things from the second half of the conversation where we were talking about beer. I mentioned a couple of the fermentation products that can be faults in beer. Diacetyl and acetaldehyde were the two that I mentioned there. There are plenty of others. One quick thing on acetaldehyde. I mentioned that the yeast, I think the phrasing I used was that it reabsorbs it, or that some yeasts don't produce that. I was trying to summarize what I was saying there. That's not exactly accurate. Acetaldehyde is an intermediary step in the conversion into ethanol from sugar. So acetaldehyde is always going to be produced in any fermentation process. The issue when it is left at the end of fermentation is because the yeast did not have a chance to finish that conversion process. So its presence is a sign of an incomplete fermentation, but it's always going to be present. Interestingly, acetaldehyde is what our liver enzymes break ethanol down into when we are processing alcohol in our bodies. Second, Sarah asked me about how lambic and related brewers clean or sanitize their barrels, and then we got lost in the conversation and I never got around to answering it. Most of the time, that's going to be an almost entirely just physical cleaning process, because it is next to impossible and not necessarily desirable to actually sterilize the wood. So there's going to be a series of steps using different temperatures of water, or even physically scraping out the inside of the wood. Might use boiling water or hot steam. It is possible to use a couple of compounds like sulfur or sodium carbonate to try to prevent or limit microbial growth. But in the end, we want a healthy ecosystem in that wood to inoculate the next batch of beer. So what we're trying to do is just physically clean out the barrel as much as possible, and then just kind of hold that in place until the next batch is ready. Really hope you enjoyed this episode of Bean to Barstool. Sarah and I love having these conversations. We have conversations that we don't end up releasing, but usually we press record and find that we get somewhere good by the end of it to share with you all. One update on the fermentation experiment that we discussed in here. The yeast cultures we're going to go with have been ordered, and Sarah will be, we'll have those in hand soon, and we'll begin the experiments. We will be documenting that and sharing what we find with it. Not sure how long that will take, but we're both very excited about it. So thanks for listening to this episode of Bean to Barstool. Thanks to Sarah once again for coming on the show. Hope you all enjoyed it. Cheers.